Right now, beneath your feet, there is an entire world most humans will never see. A place of crushing pressure, molten rivers, and temperatures hotter than the surface of the sun. But what would actually happen if we tried to drill all the way down, straight through the crust, the mantle, and into the very center of our planet? This is the story of a journey no human being has ever completed, a descent into the deepest darkness our world has to offer. And by the end of this video, you will understand why this journey would kill you in ways you cannot even imagine. Let us begin at the surface, where everything feels solid, stable, and safe. The ground beneath you feels like stone, unbreakable, permanent, eternal. But that feeling is an illusion. The Earth's crust, the thin outer shell we all live on, is only about 35 kilometers thick on average beneath continents. To put that in perspective, if the Earth were the size of a basketball, the crust would be thinner than the outer layer of paint.
We start our descent with modern drilling technology, the most powerful machines humanity has ever built. The deepest hole ever drilled by humans is called the Kola Super Deep Borehole, located in northwestern Russia. After nearly 20 years of drilling, scientists managed to reach a depth of just over 12 kilometers. 12 kilometers sounds impressive, until you realize that is less than 0.2% of the distance to the center of the Earth. At that depth, the temperature was already 180 degrees Celsius, hot enough to melt lead. The rock at that depth behaved more like plastic than stone. It would flow and close the borehole as soon as the drill was removed. This is why we stopped drilling. Not because we ran out of ambition, but because the Earth itself refused to cooperate. But in our imagination, in this video, we do not stop. We keep going. We push through every barrier the planet throws at us. Our first major obstacle lies about 35 kilometers down, a hidden boundary that most people have never heard of. It is called the Mohorovičić discontinuity, or simply the MOHO, and it marks the border between the crust and the mantle. The MOHO was discovered in 1909 by a Croatian seismologist named Andrija Mohorovičić, who noticed that earthquake waves suddenly changed speed at this depth. Below the MOHO, everything changes. The rock becomes denser, hotter, and far more hostile.
We are now entering the mantle, a layer that makes up roughly 84% of Earth's total volume. The mantle is not liquid. Most of it is solid rock. But under this incredible pressure and heat, it flows very slowly, like extremely thick honey. This slow movement, happening over millions of years, is what drives the movement of tectonic plates and shapes the surface of our world. But for us, descending in our imaginary drill, the temperature is climbing fast. We are now approaching 500 degrees Celsius. To give you a sense of that heat, it is hot enough to melt tin, zinc, and several other metals that we consider solid and permanent. The pressure at this depth is also extraordinary, about 100,000 times the atmospheric pressure at the surface. If a human body could somehow survive the heat, this pressure alone would crush every cell, every bone, every molecule of your existence. But we keep going, deeper into the mantle, where the rock begins to transform under extreme conditions. At around 410 kilometers depth, a critical transformation occurs. The mineral olivine changes its crystal structure entirely. This transformation is called a phase transition, and it fundamentally changes how the rock behaves. The the rock becomes denser. It becomes stronger, and the temperature keeps rising, now approaching 1,000 degrees. We are still only in the upper mantle, the first zone of a journey that goes much, much deeper. As we push past 660 kilometers, we cross another invisible boundary, entering the lower mantle. The lower mantle is where conditions become truly alien. Temperatures reach 2,000 degrees, and the pressure is crushing beyond comprehension. The rock here is so compressed that minerals we know on the surface exist in forms that should not be possible. Bridgmanite, the most abundant mineral in the entire Earth, exists only under these extreme lower mantle conditions. This mineral was predicted by scientists decades before it was ever found, and it makes up nearly 40% of our planet. As we descend deeper, the temperature continues to climb, now exceeding 3,000 degrees. At this temperature, steel would melt instantly. Concrete would vaporize. Most materials we build with would cease to exist. Yet somehow, the rock here holds its form because the pressure is so immense that it prevents the material from melting.
This is the great paradox of Earth's interior. The deeper you go, the hotter it gets, but the pressure keeps everything from melting. We are now approaching the halfway point of our journey, but the most dramatic change is still ahead. At exactly 2,900 kilometers below the surface, we encounter the most dramatic boundary on our entire journey. This is the D double prime layer, the boundary between the lower mantle and the outer core. Below this boundary, we leave solid rock entirely and enter a world of liquid metal. The outer core is made primarily of liquid iron and nickel, and it is the only truly liquid layer of the entire Earth. Temperatures here range from 4,000 to 5,000 degrees, nearly as hot as the surface of our sun. The pressure is now about 1.3 million times atmospheric pressure, a force that is almost impossible to imagine. It is in this violent, superheated ocean of liquid metal that something extraordinary happens, something that makes life on the surface possible. The movement of this liquid iron generates Earth's magnetic field, the invisible shield that protects every living thing on the surface from deadly solar radiation. Without this magnetic field, the sun's charged particles would strip away our atmosphere, turning Earth into a dead, irradiated wasteland like Mars. So, in a very real sense, this churning ocean of liquid fire 2,900 kilometers below your feet is what keeps you alive. But for us, continuing our imaginary descent, this is not a place of safety. It is a killing field of liquid metal. The currents here move at speeds of several kilometers per year, carrying enormous amounts of heat energy from the inner core outward. These currents are responsible for the convection cycles that have driven plate tectonics for billions of years, shaping every mountain, every ocean, every continent. The outer core is roughly 2,200 kilometers thick, a vast ocean of metal that we must cross to go deeper. As we push through the outer core, the temperature keeps climbing, approaching 5,500 degrees. At these temperatures, our imaginary drill, no matter what it is made of, would be vaporized in an instant. But we press on, because what lies ahead is the most extreme environment on our entire planet. After crossing the entire outer core, we finally reach it, the inner core of the Earth. The inner core begins at a depth of about 5,100 kilometers and extends to the very center of our planet.
Despite the unimaginable temperatures, over 5,000 degrees, the inner core is solid. It is solid because the pressure at the center of the Earth is about 360 gigapascals, 3.6 million times atmospheric pressure. This pressure is so extreme that it overcomes the intense heat, forcing iron atoms into a rigid crystalline structure. The inner core is approximately 1,220 kilometers in radius, slightly smaller than the Moon. It is made primarily of iron, with some nickel and lighter elements mixed in. Scientists believe the inner core is slowly growing, gaining about 1 millimeter of new iron per year as the outer core slowly cools and solidifies. This means the inner core was once much smaller and will continue to grow until billions of years from now, the entire core becomes solid. But here is something fascinating. The inner core is not still. It rotates. It has its own rotation, slightly different from the rest of the Earth. This independent rotation creates complex electromagnetic interactions with the outer core, interactions that may influence the strength of our magnetic field. Some scientists think variations in this rotation could be responsible for magnetic pole shifts, events that have happened many times throughout Earth's history.
We have now reached the deepest point of our journey, the very center of the Earth, 40,000 kilometers from the surface we started on. At this point, the pressure is at its absolute maximum, about 360 gigapascals. Every direction you look is deeper into the core. The temperature here is estimated at about 5,400 degrees, a number so extreme it is difficult to even contextualize. The temperature here is estimated at about 5,400 degrees, a number so extreme it is difficult to even contextualize. Now, let us confront the terrifying question: what would actually happen to a human body on this journey? First, let us address the heat. Even in the shallowest parts of the crust, temperatures would cook you alive within minutes. By the time you reached the upper mantle, your body would be completely incinerated, reduced to nothing but scattered atoms. But even if we somehow protected you from the heat, the pressure would kill you long before the temperature became the problem. At just 10 kilometers depth, barely scratching the surface, the pressure would crush your lungs and collapse your ribcage.
The water in your body, and your body is mostly water, would behave in strange ways under these pressures. At certain depths, water enters exotic states of matter that scientists have only recently been able to recreate in laboratories. Your DNA would be shredded. Your proteins would unfold. Every biological molecule that makes you who you are would be destroyed beyond recognition. There is no technology that exists, or is likely to exist for centuries, that could protect a human body at these depths. The deepest any human has ever been is about 3.8 kilometers in the ocean, inside a specially designed submarine. The deepest any drill has ever reached underground is 12 kilometers, and that is less than 1/3 of 1% of the way to the center. The center of the Earth remains the most inaccessible place on our planet, more remote than the farthest reaches of deep space we have explored with robots. And yet, without this extreme environment at the center of our planet, life on the surface would be impossible. The core generates the magnetic field. The magnetic field shields the atmosphere. The atmosphere keeps the oceans liquid, and liquid oceans gave birth to life. Every breath you take, every heartbeat, every moment of your existence depends on forces happening 5,000 kilometers below your feet.
This is the hidden truth of our planet. The most important part of Earth is the part we can never see. In the future, humanity may develop new technologies, perhaps neutrino imaging or seismic tomography, that allow us to see the interior without drilling. Imagine a future where we can see the core as clearly as we see the ocean floor, mapping every current, every crystal, every pocket of exotic matter. But for now, the center of the Earth remains a mystery, a place of extremes beyond human experience, a reminder that we live on a thin shell above an alien world. And perhaps that is what makes this thought experiment so powerful. It reminds us how little we truly understand about the world beneath our feet. Every volcano, every earthquake, every shift in the magnetic field, all of it originates from this hidden interior world. The Earth is not a dead rock. It is alive, churning, flowing, generating, transforming, every single moment of every single day. And we, fragile, temporary beings living on the surface, owe everything to forces we can barely comprehend, at depths we can never reach. The next time you feel the ground beneath your feet, remember, there is a whole universe of fire and iron waiting in the dark below. Thank you for descending with me to the center of the Earth. Stay curious, stay amazed, and never stop asking what lies beneath.